Hi, my name is Connor, and I'm a data scientist at Predibase, the low-code declarative machine learning platform. Today I'll be walking you through an end-to-end use case for audio classification in Predibase. We're going to cover a few key user journeys including connecting data, declaratively training and iterating on models, and querying those models using a language we call SQL. We'll start by connecting some data. Predibase makes connecting data fast and easy with only a few clicks. You can connect from structured data sources like Snowflake and BigQuery. You can also connect to object storages such as S3, ADLS, and GCS. Let's take a look at the dataset we're using today. We can see that each row corresponds to an audio recording of a patient taking a breath. Each patient has multiple breath recordings, so we can note that the row-to-patient mapping is many to one. We also have some additional information such as the chest location where the recording was taken, the type of recording equipment used, and some general patient info such as age, sex, BMI, and weight. The goal of this prediction exercise will be to train a model that can diagnose whether a patient's lungs are healthy or unhealthy. This model will ultimately produce actionable insights that physicians can use to indicate whether a patient needs further care. Now that our data is connected, let's go ahead and start training some models. This is our model repository where teams can collaboratively train, version, and iterate on models. Training the first model in Predibase is really easy. All I need to do is specify the dataset, the target, and then click Train to get our first model. Now that our model is trained, we can select the model version to see a variety of model analytics that can help us better understand the model's performance. These include the learning curves, which show metrics like loss, ROC, AUC, and accuracy, as well as other model analysis tools such as confusion matrices, F1 plots, and much more. We can also take a look at the underlying Ludwig configuration, which effectively gives us a blueprint for our entire ML pipeline. In this particular scenario, our model is only receiving about 69% accuracy. Let's see if we can train a new model version with some additional parameters to improve the model's performance. For this new model, let's add in a couple of additional features. I also want to add in some dropout to a few places around the model as well. Finally, let's turn on mixed precision in the trainer. Now that we've specified our new parameters, we can send our second model into training. Let's fast forward so we don't have to wait for the model to train. It looks like our model got about 94% accuracy. Excellent. Now that we're finally happy with our model, we want to bring it into production. All I have to do to productionalize this model is click the Deploy button in the top right-hand corner, and Predibase will create a managed deployment where you can query the model in real time from a REST endpoint. Another way we can operationalize our model is with SQL. Here we have a basic SQL query that selects 10 rows from the respiratory pathology detection dataset. However, by adding this one line, I can easily transform that SQL query into a predictive SQL query. I now have access to the predictions from the model right here as an additional column in the dataset. Here I chose to predict on a random sample of the dataset, but I can just as easily predict on any data that follows the same schema. I can also extend this SQL query by adding the with explanation clause. What this does is provide global feature explainability to show the key drivers that influence the model's predictions. Additionally, I can view these explanations at a row level to further assist in model debugging. Lastly, I can use SQL to productionalize our models by writing back out to one of our connections. Furthermore, I can put these queries on a schedule if I want to run them on a specific time interval. Today we've seen an end-to-end example of how easy it is to generate a solution for a respiratory pathology detection use case in Predibase. If this sounds interesting, feel free to reach out and request a demo.